we're looking at the data component. It's one of the utilities component over here. And when we zoom in on it, we have 3 different tabs. We can have a look at the economics first. So what this does is, first of all, it tells the software which data to use. And there's 2 kinds of data. There is some predefined data that the users don't have any influence on, and there is some local data that actually should be set at the very beginning of every project. So some of them are only for information. So when we look at the maximum investment and maintenance cost, it's essentially helping us here with the dashboard, where we're saying what is the value to scale these bars against. So if we were to bring them down, you can see that now maximum investment cost over here is 75 euro. So it's just changing the scale of this yellow colored bars over here. Is not changing the values at all. The same thing would be true for the maximum maintenance cost, and really depends on the utility of these 2 sliders. Is only visual. It helps in communicating the results. Depending on your geography, on the type of projects, maybe 500 euro a square meter wouldn't be unheard of, or it might actually be too low. If you find yourself that you're maxing out the slider, you can always double click on this little circle over here and then change the max value to, for example, 700 in this case, and you'll be able to bring it back up all the way there. Then the next ones over here are actually site specific, and then we need to understand what are the for our potential savings. If I close these, for our potential savings over here, there is some potable water fees and stormwater fees, and then right now they don't do much. As you can see, they're at 0 because we don't have any storage elements that will be helping us to save water. But then the potable water fee expressed in euro per cubic meter would tell us, okay, how much money, if we were to collect some stormwater and use it for irrigation or building use, toilet flushing, then how much money could we save per year. Same thing would be true for stormwater fees. Some municipalities actually have a fee per associated per square meter of surface that has been made pervious, and then we can calculate these fees over here. Also, for CO2 fees, there is some emissions bonus that some municipalities or some countries or some regions would introduce to encourage more trees, essentially, or more green areas in developments. And then here we would define what is this cost, and it will be multiplied by the amount of how many tons. So this is per ton of CO2 avoided, and then or taken out of the atmosphere. And then if we were to calculate this amount, how much CO2 are we actually taking out of the atmosphere, we would multiply it by this fee. Going further, we have some inputs that are needed for the green factor score calculations. It's all explained in the green factor section, but then we just need to define these 2 inputs are needed and necessary for us to understand what is the target value for the green factor score. Everything happens in the background. All the calculations we just define is the area, the project area, mostly office, commercial space, industrial, or residential, and do we have is there at least 1 meter of permeable soil between surfaces and the groundwater table? And then if yes, then we can safely infiltrate. If no, then this will allow us to have a lower target value of the green factor score. By default, this value is set at 1. If you need more information, do have a look at the documentation related to the green factor score. It's available online, and it's very nicely presented. Then there is the water aspect of it, and here we have a few sliders to go through. So first of them is what is the design year event that we're sizing our detention elements for, right? And this is expressed in millimeters. So we can easily say, so for example, right now we have 0 detention volume, but if we were to introduce very quickly a detention volume component, so detention basin, I'll just set this one over here and put it over there. We can see that with our current design rain of 17.8 millimeters, we are hitting only 52% of the requirement with 9 cubic meters worth of storage that we have on site. But this rain event might correspond to, for example, like a 10-year event. And then if we looked in our tables, and then we would know that, for example, a 5-year event is only 8 millimeters. Then we can easily see that for our 5-year event, we already have more than enough of storage with the same amount of storage. And the same thing would be true if you went to, for example, a 100-year event that corresponds to 28.5 millimeters. The runoff limit does kind of like the opposite. Some municipalities allow you to let some water run off the site and get away with it, right? So it doesn't need to be included in your detention volume calculations. So the higher this runoff limit is, and its value is in millimeters per square meter of your site. So the higher this is, the more it is allowed for your precipitation to leave the site. And by default, this is set to 0. If your municipality allows that, you can just hover over the number over here, and then understand how to calculate this value. For natural evaporation, infiltration, and runoff, they all come to this natural water balance calculation. Essentially, what we need to input here is what are the percentages of these 3 components in natural conditions for your site. And then depending on where you are in the world, they will be different. But this is roughly a good starting point for your calculations. Do look it up, and then one thing to remember is these are percentage values, and when you hover over these headers over here, you'll have a little bit of a help in form of a tooltip that tells you these values are in percent, and they also should add up to 100%. So if I do something like this, like it will completely skew the results, because I need to then make sure that, for example, if I set this to evaporation component to 80%, then this should be 10, for example, and this also should be 10 or 11.9, so that altogether they add up to 100. And the last one over here is which design year do we want to look at? And this slider doesn't do anything unless we connect this input over here, the daily file. And where do we find daily precipitation files? If we go to the M drive, again, I already put them all there. So under trans GreenScenario, there's data, and there is GHCND stations. So first of all, we would need to look into this file, and it tells us it has a list of all the meteorological stations in the world, and there's a lot of them. there is a few thousand inputs in this file. And then what we'll do is we'll search for one that we're interested in. So let's just search for a location in Berlin. And we can see there's a few, there's some in Potsdam, there is Berlin-Dahlem. But then let's say that we're interested in this one. So what we would do is we would look essentially at this first input over here. It's the name of the station. So GM multiple zeros and 3319. And now we would go to the GHC and the all folder, and then looking again, GM. So let's do GM 0003319, GM 0003319. This is our daily file. And the best would be to just copy this file and put it somewhere where we can easily find it. So I'll just copy it and paste it to my desktop. And then from here, I'll just select one file. My daily file is over here, connected. And then now I can see that I can just scroll through it, and then this daily file has daily information on precipitation going back to, for the case of Berlin, to 1876. And depending on the location that you're at, you would have different time spans, but you would be able to then select which year you want your potable water savings calculations to be performed against. So you can see, for example, here 1994 was a relatively humid year. There was a lot of precipitation, whereas 1990 was much less, and 1985 even less, right? So this way you could see, what are the patterns, and then for 2021 it's not a full year yet. That's why at the time of the recording the values are only until April. So we would just look at a full year. In this case, for example, 2018 was an extremely dry year, and then we could select this one and say how much water are we able to save in a dry year? How much would it be compared to a 2013 when there will be more precipitation? But essentially, this is how you would work with the data component, and these are all the inputs necessary. And I highly encourage you to actually start all your projects with filling out all these data, and also revisiting them every now and then to make sure that everything still is intact. Make sure that, for example, these values, they all add up to 100, that you're working with a design year or design rain volume that makes sense for your site, that you're looking at the year, that you have connected the relevant daily file, and so on and so forth.